Yes, any two ordered pairs, so we can illustrate with finding the midpoint and the distance. -2 and 6, awesome. 3, -5, awesome. Let's find the midpoint of the line segment that connects these two. Please add up the x's. Perfect, 1/2. Please add up the y's. That's it. This is the midpoint. You picked it. I didn't do anything. So now let's determine the distance. I recommend writing the formula. x2 minus x1 everything squared plus y2 minus y1 everything squared. I recommend do this, but it's up to you. Label the points as x1, y1, and x2, y2 as we did from the beginning. And write 3 under x2. Write -2 under x1. Write -5 under y2. And write 6 under y1. If you like this method, if not, you can write it again. It's up to you. So, any questions? Let's do this together. 3 minus -2. Excellent. 5 squared, please. Excellent. Plus -5 minus 6 squared. 121. So this is the square root of 149. And I don't think we can do anything to 149. This is it. This is how we determine the midpoint and the distance. And now, final step in this chapter. Here's a circle, and the center by convention, coordinates are h, k. And what do you think this is? Very good. I'm going to name this point that I can name anywhere on the circle, A of coordinates x, y. So I will refresh your memory on the definition or the formula that is the distance formula. x2 minus x1 squared plus y2 minus y1 squared. Or the other one, d squared equals x2 minus x1 squared plus y2 minus y1 squared. And I would like you to, in this formula, I would like you to plug in this point, and the radius.
Are we squaring it because the radius is 5 the diameter, or what is squared?
We use the Pythagorean theorem.
Oh no, I didn't see it on the outside. What did you want?
So we use the Pythagorean theorem here. One leg squared plus the other leg squared equals the hypotenuse squared. And then because we wanted to find the distance, we took the square root from both sides. So I can use either this or this. Is that clear? They are the same? Oh, awesome. Good. So now please tell me how to plug this in. So let's say x2, y2 is this. And this is x1, y1. I went it the other way, actually. It doesn't matter, really. So instead of D for the circle, what do I write? We are talking about the distance between, it's a distance, right? We're talking about the distance, right? The distance between C and A. It's r, right?
Right.
The left-hand side. It's r squared, correct? That's the distance between C and A, right? Now, what do I write?
X.
Very good. X minus h squared. Awesome. Plus. Very good. This is the equation of the circle. Is a circle a function?
No.
Absolutely not. It's a relation. So that's the equation of the circle. Where does it come from? From the equation of the distance. By simply applying the equation of the distance between any point on the circumference and the center. That's how we determined it. We didn't do anything. We just replaced the letters with something else. There are three different types of questions here. Three different types. From the easiest to the most difficult. Number one. Given the center, -2, 0, and the radius equals 4, find the equation of the circle and graph it. So we are given the center, which is -2, 0. We are given the radius, which is 4, and we're asked to find the equation of the circle and then graph it. Can anyone tell us what to write? Excellent. 16 equals. X.
Oh, minus 2.
Yes, x minus -2, which is x plus 2 squared, plus y minus 0, which is y squared. This is the equation of the circle centered at -2, 0 with a radius of 4.
How did you get 16?
I squared r.
Wait, what is this H and K? I can do all that.
Yes, h and k are the coordinates of the center. This is by convention. Yeah, you can use other letters, but still, this is what we normally use.
Okay, I just didn't.
That's okay. Now let's graph it. Of course, I will start by graphing what? Or plotting what? Of course. And then I will create 4 points. One north, east, west, and south. How many units away from the center?
4.
Exactly. Excellent. Thank you. So this is the center. 4 units. 4 units. 1, 2, 3, 4. 1, 2, 3, 4. I know it's not going to be a circle, but please bear with me and say it is. You already told me it's not a function. However, even a relation has a domain and range. It is a relation, so please give me the domain and give me the range. Yes, -6, 2. Excellent. And the range? That's easier. That's it. Excellent. So this is the first type. We're given the center and the radius. We're asked to create the equation and then graph the circle.
How did it get?
Say it again.
How did it get 6 again?
You mean this, -6?
Yeah.
So it's 4 units away. If this is -2, then I have -6. If this is -2, 4 units away is at 2.
And the long, with the domain, the highest too.
No, the range is from the lowest to the highest, and the domain from the left to the right. Is that better?
I think so, yeah. So it's 2 because it's the highest, the domain.
It's between -6 and +2 because the center is at -2 and I have 4 units to the left and 4 units to the right for the radius. When I create these 4 points, I have to measure the radius. The radius is 4. So we are 4 units to the right, 4 units up, 4 units down, 4 units to the left.
And that's how you get 62.
In order to find the 4 points. I could find 10 points, but then I'll spend too much time on that. So I'm only happy with 4 points. Is that better? Do we understand the domain and range on this? Everyone? Yes? Yes? Charisse? Do you understand that this is the center?
That's the center of the circle.
Right. And do you understand that the radius is 4?
Yes.
All points have to be 4 units away from the center. We understand that.
Yeah.
So then this must be 4. If this is -2, then this must be 2.
Got it.
And if this is -2, this must be -6. So then the domain is -6 to 2.
Okay.
And the same thing for bottom and top because this is at 0, so 4 and -4.
That's good. Okay.
Better?
Yes.
Everyone? Okay, perfect. Second type. Given the equation of the circle, x plus 3 squared plus y minus 1 squared equals 9. Find the center and the radius. Yes, you can graph it if you want to. I think one graph is enough unless you want me to graph more. Center, please. And before you say anything, let's compare. X minus a number. Minus has to be in the formula. Y minus a number. Squared, squared, and a positive number here. If this is 0, that's just a point. If the radius is 0, there is no circle. It's just one point. If the left-hand side is negative, that's not the equation of a circle. Not possible. So, that's it. And the radius? That's it. Do we understand how we get -3, 1 and the radius of 3? Everyone?
I'm sorry. I missed it.
So if you go back to the equation of the circle, with -3, 1, -3, x minus -3 will give us x plus 3. And with 1 will be y minus 1. So that's why I pointed out to the fact that it has to be a negative. So if this is +3, then h is -3. X minus -3 will be x plus 3.
So usually
So this will be rewritten as x minus -3 squared plus y minus 1 squared equals 9. Therefore, this is h and this is k. Is that okay? Is everyone in the clear why we get -3 and not +3? Yes? Yes, Denny?
Because you're taking the number with between h and x, and you're plotting the point 3 to the left.
That's
to make
also
it
a very good.
-3.
That's also a very good explanation. Yes. Or you say x plus 3 is the same with x minus -3. Therefore this is the h. By comparing it to x minus h squared plus y minus k squared equals r squared. So that's how you get the h to be -3 and the k to be +1 and the radius to be 3. Is that better? Everyone? Okay, so there is one more type, and here it is. And I cannot make this one up on the top of my head, so I have to let you choose, or I will choose. On page 332, Let's start with 55, and then you choose the next one, because I'm sure we are going to look at one more, at least. 10x minus 6y minus 30 equals 0. So the question here is this a circle? Is this the equation of a circle? My answer is no clue. Here's why. Here's my answer. If, at the end of the day, I can present this like this, then I'll say yes. If I cannot present this like this, then I'll say no. It's not the equation of the circle. If it is the equation of the circle, they also want us to find the center and the radius. So let's copy the equation of the circle right here to have it under, oops, under radar, right here in front of us. Good. What do you think we need to do to this to get it like this?
No. Substance. Well, replace it.
Close. Close. Yes. I would say 95% yes, but I'm missing one more word in there, or two words.
Yeah, move it around.
Say it again.
Factoring polynomials.
Nope. No, you are on the right track with factoring.
Move the line.
No. Okay, let me give you my hint. When we solved quadratic equations, we looked at how many methods? And I said one of them, thank you. That's what it is. That's what it is. You observe here a completed square with x and some number, right? You observe here a completed square with y and some number. And some number on the other side. That's it. We want to complete the square. That's why we studied complete the square a long time ago. And I said, that's not for solving quadratic equations because it alone does not do the job. We complete the square and then we have to take the square root. But this is what it is for. Ready? I see an x squared and I see a negative 10x. Please tell me what to add to both sides in order to complete the square for x. Negative 10 divided by 2?
25.
Very good. It's negative 5 squared. Positive 25, remember, to both sides. Now this, and this, they are all here. First day of classes, that's why I tortured you from the day one. A binomial squared, 1, 2, 3 terms. Say it again. Exactly. The first term squared minus 2 times the first times the second plus the second term squared. Of course. Now these, do not cross it out like that. These are done. These 3 terms are here in this binomial squared. Plus, now I want for this and this, what should I add to both sides? Middle coefficient negative 6. 9, very good. Plus 9, plus 9. So now this and this and this are here. Exactly what you gave me. It must be y minus 3, right? There is nothing else. So now let's see what we have not used yet. I have not used this, I have not used this, and I have not used this, which has to be transferred to the other side. So a 30, a 25, and a 9. Excellent. Now, if you ask me, Is this the equation of the circle? What do you think I'm going to say? Yes, it is. And I can identify the center, and I definitely can identify the radius.
There's like a different, I don't know, this is just kind of a hot mess. Like, maybe it's just all the marker and stuff. But
Right, because we are doing two things in the same row. That's why it looks. Yeah, we can write it out.
prettier.
Yes,
More open.
yes,
So we're gonna do another one of these though, right?
yes.
15x though.
I'm sorry.
Wasn't there 10x plus 25, right?
Yes,
So
x squared minus 10x plus 25 is in here. They're all in here. 1, 2, 3. Because a binomial squared is a trinomial. And then y squared minus 6y and plus 9 are all three in here, because y minus 3 squared is a trinomial. And then we move the 30, and we have 9 and 25. So let's look at one more. Let's say 58. X squared plus y squared plus 12x minus 6y minus 4 equals 0. What will you tell us to add to both sides for x squared plus 12x? Exactly. Now 1, 2, and 3. Please, Cece.
How do you get it right, sir?
From the complete the square method, we identify the middle coefficient, we divide it by 2, and we square that number. 12 is the middle coefficient. So the middle coefficient is 12. We divide it by 2 and we get 6. And we square 6 to get 36. What do we have in parentheses? If this is plus 12, we can,
X plus.
indeed. So now, for y squared, negative 6y, what do we need to add to both sides? Exactly the same thing we just had. So now this, and this, and this are here. Yes, but this, because it's negative, it will be y minus 3. Good. So let's see what we have not used yet. We have not used the positive 9, we have not used the positive 36, and we have not used the positive 4. Which is? So 4 plus 36 is 40, 40 plus 9 is 49. Is that okay? Now, can you answer whether this is the equation of a circle? Yes. And the center is 3, and the radius is 7.
Are we adding the 9 to 49?
Yes. Yes, because I have to bring the 4. So when I add 9 to this side, I have to add 9 to this side. When I add 36 to this side, I have to add 36 to this side. So yes, I have a 4, a 36, and a 9 on the right-hand side. 36 plus 4 is 40, plus 9, 49. Is that okay? Now, do you feel better, Ella, about this? I know the first one looked a little messy. Yes? Ella?
Yeah, it's better. It's much better.
Yeah, the first one is, always a little bit confusing.
So what would it, can you show some examples of something when it would be a circle?
Yeah, so I mean, I can look it up. I can't create an example.
Like what do we have those words like how
Not really. You will complete the square and you get. Yes, you can complete on anything, but if it happens that the right hand side is 5, negative 5, so if I don't change anything, but if it happens that this is okay, this is okay, but here I get negative 49, that's not a circle,
Okay.
because I cannot take the square root from negative 49. Or if it happens that I get a 0 here, that will not be a circle,
Okay.
because it cannot. There is no circle with a radius of 0. Good. Any questions?
It has to be a number that's squared. It can be squared.
No, not necessarily. It can be 3, because the radius will be the square root of 3. No, but it cannot be negative or 0. Yes. Any questions? Okay. Chapter 3. Chapter 3 deals with several things. Polynomial functions. And the second topic, rational functions. We start with polynomial functions, but 3.1 is quadratic. So let's list what we're going to look at when it comes to polynomial functions. Linear is the easiest and the simplest possible the polynomial function. This is done a long time ago. We're not going to talk about it. Quadratic. This is what we are going to look at 3.1. And then polynomials, degree, 3, 4, 5, and so on and so forth. Quadratic should have been known. I will not assume that. I will go through the whole thing again. So quadratic functions can be given to us in 2 different ways. Here's one way, ax squared plus bx plus c. And here's the other way, a in parentheses x minus h squared, not to be confused with a x coordinate of the center of the circle. It has nothing to do with that. It happens that we like to use this h and k, but they are not connected at all to what we've just seen in circles. Okay, so for now, let's start with the first option. I'm going to pick a problem, and we're going to go through step by step graphing it. We're not going to get the chance to talk about this today, okay? Just the first one. So let's look at an example like negative x squared minus 4x and minus 3. Is this a quadratic function? Please say yes. Yes, it's a quadratic function. The leading coefficient is -1, the middle coefficient is -4, and the last, or the free term, if you want, is -3. We agree with this so far? Perfect. Okay. In the first, so the question here is, what is the target? What are we trying to do? Graph f of x. This is what we are trying to do. Not using transformations, we can't do that on this function. So in the first step, I have to find the domain. Every time I'm asked to graph a function, I have to start with the domain. Okay, so what would you say the domain of this function that is polynomial, or any polynomial function forever? Unless we truncate the domain. Exactly, unless we truncate the domain because we want to make a one-to-one function. That's a different story, right? We want to make this into a one-to-one. That's why we say 0 to infinity, but that's not the case. In general, all polynomial functions have domain all real numbers. Perfect. Number 2. Shape. What does this mean? There are 2 possible shapes for quadratic functions. This is one possible shape, and this is the second possible shape. This one has a minimum, and this one has a maximum. Both points are called vertex or vertices, but vertex singular. Vertex. The vertex here represents a minimum. The vertex here represents a maximum. It is related to the leading coefficient. Do you remember we graphed x squared many times? What was the leading coefficient of x squared? Positive, right? Good. So when the leading coefficient is positive, the quadratic function or the parabola, the graph of a quadratic function is called parabola, opens upward. When the leading coefficient is very good, the quadratic function or the parabola opens downward. So this is the case for a leading coefficient that is positive, and this is the case for a leading coefficient that is negative. Can anyone tell us in this particular instant, for this function that we are looking at, is the shape going to be opening upward or downward? Very good. So the parabola in our case has a maximum because a is -1, and when we graph, it will look like this. Step number 3. The vertex. The vertex, like any point, has how many coordinates? Of course, 2. So this will be the x coordinate of the vertex, and this will be the y coordinate of the vertex. The question is, how do I find the x coordinate of the vertex? Bear with me for a second. Can anyone dictate the quadratic formula? And you can say, what does this have to do with anything? In a moment, I'll explain. Plus or minus square root of b squared minus 4ac over. Very good. The reason why I put the quadratic formula there is because I would like you to connect the two so you can easily remember the x coordinate of the vertex. This is the x coordinate of the vertex. Okay? So then, -b over 2a. How do I find the y coordinate of the vertex? Exactly. Thank you very much. Awesome. Thank you, Michelle. -b over 2a. Of course. If I find 5, then I have to plug it in the function to find the y coordinate. If I find 10, then I have to plug it in the function to find f of 10. That's always the rule. If I'm giving you a function, f of x, and I'm telling you x is 5, find the y coordinate, you'll have to plug it in. That's the definition, right? Is that okay? So let's find, you'll understand in a minute. So let's find -b over 2a. Negative is from the formula. What is b again in our problem? What is 2 times a in our problem? Perfect. 3 negatives, don't forget. So then it's -2. So I already have the x coordinate as being -2. How do I find the y coordinate again? Plug it in, of course. So f of -2 will be -2 squared minus 4 times -2 minus 3, right? If I have x, the y coordinate is determined by plugging it in. So -2 squared. 4 with minus in front. -4 times -2. +8 and minus 3, and this is +1. So the x coordinate of the vertex is -2. The y coordinate will be 1. Any questions? Any questions? Step, yes?
Yeah, you lost me at f of -2. Where are you getting the rest of it? Is that the rest of the I don't understand.
This is the vertex.
Yeah, no, I understand that.
So I determine the x, and I have to plug in the function to determine the y value. I cannot plot a point if I don't have both coordinates. So I determine the x coordinate to be -2. I have to plug in -2 in the function to get the y coordinate.
What function?
What function?
Okay, this is where I'm getting confused. I kind of want you to like establish like names and stuff before we like, because the problem's like all the way up there, and I'm like lost.
So we're given this function and we're trying to graph it, and these are the steps we have to follow.
Okay.
It's a long list of steps. I wish I could write all of them on one page, but I can't. I have a lot to explain.
I think that's where I'm getting confused because it's like we go through like
So in order to graph this function, I have to go through 8 steps. In the first step, domain. Step 2, the shape. Step 3, I'm finding the vertex. In step 4, the first problem is always, if you are a little bit patient with the first problem, the second one will take 3 minutes. But the first one is always long because I have so much to explain. Yes?
And we just reference back to the function at the top.
Yes.
Okay.
This is our function.
I
This
think
is
that's probably,
that's
yeah.
what I'm getting
I think when, maybe because it's so long, if you could just write the
the steps
function
out.
over since we going, like since we
Yes.
are continuing, just what we're plugging the -2 into, because we haven't seen it.
Yes, it's right here, f of -2.
But it would have been f of x equals -x squared minus 4x minus 3.
Yes.
See, we
If we could just repeat that,
Yeah.
like I know it's like extra writing, but it's like it's just been so far up and we've gone through so many.
Oh, you want me to write the function one more time?
Just so we can like.
That's
implement
fine.
it.
Oh, that's no problem. -x squared minus 4x minus 3.
and this is
So we found the vertex. -2, 1. Is this okay now? Is it?
Yeah.
Okay, perfect. Next step will be x-intercepts. When we get to graphing polynomial functions, the list will be even longer. X-intercepts and the comma, if they exist. If they exist. What does that mean? So one more time, we established that this function, -x squared minus 4x minus 3, has a max or a min? Max. Here are all possible cases for a max. All possible cases for a maximum. Here's one. Here's the other. And here's the third one. How many x-intercepts, in case this function looks like this, how many x-intercepts does it have? 1. So one real solution for the x-intercept. Is this going to be the vertex as well? Correct. So if there is only one real solution, that is also the vertex. In the second possible situation for a maximum, how many x-intercepts? How many solutions? 2 real solutions, or x-intercepts. What about in the last situation? How many real solutions? No real solutions. Very good. Why do I need to think in these terms? Because I don't want to waste my time. In which of these 3 situations I will be wasting my time? In the last one, I will be wasting my time because I won't find solutions. Also, in the first one, I will waste my time because I already found the vertex. So only this one makes sense to spend time on, not on these 2. And now I'm ready to establish whether it's this or this or this based on the vertex. The vertex is -2, 1. Can the first situation have a vertex of -2, 1? No, because the y coordinate must be 0. It's not the case. Let's jump to the last one. Can this one have a vertex of -2, 1? The vertex is under the x-axis, so the y value will not be positive, but the y value will be negative. So it's not the first one because the y is not 0. It's not the last one because the y is positive. It must be this. It gets to the positive y. Can you already establish the range? We haven't even talked about the range yet, but can you tell me the range, knowing that the vertex is -2, 1 to 1? I know it's 8:31. I will have to stop unless you want me to continue, but I have to give you the option. So we didn't get the chance to graph it, and